So, hello everyone. This is our presentation on binary positive tree by Group 5. So, our members are Saksham Dungana, Alex Legal, uh, me, myself, Prasiddha Thapa, Nikhil Ale, and Binit Sapkota. Next slide. So, the table of content for our presentation is acknowledgement, the introduction about the topic, key features, example, importance, insertion and deletion, file system, and finally the references that we used in this presentation. So, next slide. So, what is binary positive tree? Binary positive tree is a type of self-balancing tree data structure used in computer science to store and organize large amount of data. It is commonly used in databases and file systems for efficient data and indexing. The structure of a binary positive tree is similar to that of a binary negative tree, but with some key differences. In binary positive tree, the internal nodes contain only keys and pointers to other nodes, while the actual node is stored in the leaf nodes. The leaf nodes are connected in a linked list to allow for efficient range searches. A binary positive tree is designed to maximize the number of keys that can be stored in each node while still maintaining a balanced structure. This allows for a faster access to data because the number of nodes that must be transferred to find a specific key is minimized. The binary positive tree is also self-balancing, which means that the tree will automatically recognize itself as nodes uh, and are added or removed to maintain an even distribution of data across the tree. In a binary positive tree, the data across the tree is sorted in order of the leaf nodes. This allows for efficient range sources because the tree can quickly locate all the keys within a certain range. Additionally, because the leaf nodes are linked in a linked list, the range sorts can be performed quickly by traversing the linked list. Uh, the internal nodes of the binary tree store only the keys and pointers to other nodes. The keys are used to locate the correct child node to transverse in order to find the desired key. The nodes are also designed to be as small as possible, which allows for more of them to be catch uh, in cached memory. So next is our friend to talk about key features of binary tree.
Mute the section.
Uh, One of the key features of binary positive tree is their ability to efficiently retrieve data based on a range of values rather than just a single key. This is accomplished through the use of the linked list of nodes which allows for fast traversal of all the values within the given range. This can be especially useful in database applications where it is common to search for records based on a range of values such as records with a date within a certain time frame. Another important aspect of binary positive tree is the self-balancing nature. This means that as data is added or removed from the tree, the tree is automatically rebalanced to maintain a uniform distribution of data across the across all the nodes. In order to achieve this self-balancing behavior, binary positive tree use a variety of techniques to split and merge nodes as needed. When a node becomes full, it is split into two new nodes, and the middle key is moved up to the parent node. If that parent node is also full, the same process is repeated until a node is found that has room to accommodate with its neighbor. Accommodate the new key. Conversely, when a node becomes too empty, it may be merged with its neighbor node to form one larger node. This process continues up the tree until the balance is restored. These split and merge operations can be complex and care must be taken to ensure that they are performed efficiently and correctly. One of the key design decision in a binary positive tree is the order of the tree, which determines the maximum number of keys that can be stored in each node. The order of a binary positive tree is defined as the maximum number of children that an internode can have. The values is typically chosen based on the size of the availability of memory and the size of the data set. Now we move on to the importance of binary positive tree. Or slide. Oh, sorry, example.
Alex.
Choosing the optimal order for the binary positive tree can be challenging, as it involves balancing a number of factors such as the size of the available memory, the size of the dataset, and the frequency of insertion and deletion. In general, higher order result in fewer levels in the tree and faster source times, but may be less efficient for insertion and deletion. Another important consideration in a binary positive tree design is the choice of index key. The index key are the value used to locate data within the tree and can have a significant impact on the performance of the tree. In general, it is the best to choose index key that are selective, meaning that they are likely to partition the data into smaller subset. For example, if a database contain records for all the people in the country, the index key of a name will be very selective as there are likely to be many people with the same name. A better index key might be a zip code as this is likely to partition the data into smaller subsets. In summary, binary positive tree are a powerful and efficient data structure that is widely used in the database system and other applications that require fast access to large amount of data. And their self-balancing nature and efficient range search capabilities make them an ideal choice of many applications. However, their implementation can be complex and careful consideration must be given to the choice of the tree order and index key to ensure optimal performance. And in addition to their use in database, binary positive tree are also widely used in a file system to manage the storage and retrieval of data on disks. And file system that uses mm, binary positive trees are known as binary positive tree file system or binary negative trees file system. And the next one is slide 0.
So the next one is insertion and deletion. Uh, so in order to maintain the balanced structure of the tree, when a node is split, the middle key is moved up to the parent node. If the parent node is full, it is also split, and the process continues up in the tree till a node is found. This has room to accommodate the new key. This process ensures that the tree remains balanced and search remains efficient. So talking about inserting a new key into B positive tree involves finding the correct leaf node and inserting the key in the appropriate position. If the node becomes full, it is split and the process continues up the tree until a node is found that has room to accommodate the new key. Uh, so in deletion, deleting a key from a B positive tree involves locating the correct leaf node and removing the key. If the node becomes too empty, it is merged with its sibling nodes and the process continues up the tree until the balance is restored. The B plus tree is a powerful and effective data structure that is widely used in database system and another application and requirement fast access to larger amounts of data. Its self-balancing properties and efficient range search capabilities make it an ideal choice for many application. However, it is implicate however, its implications can be complicated and must be taken to ensure that the tree remains balanced and efficient as data is added or removed. So moving on to next slide. Vinay is gonna-
In a file system, the B-positive tree is used in main to maintain a hierarchical index of the files and directories stored on the disk. Each node in the tree represents a block of data on the disk and contains information about the files and directories stored within the block. When a file is read from the disk, the file system uses the binary positive tree to locate the mm, block containing the file and then reads the data from the blocks. When a file is written to the disk, the file system uses a binary positive tree to locate an empty block where the file can be stored. One of the advantages of using the binary positive tree file system is that it allows for efficient searching and retrieval of files based on their name, size, and other attributes. This is important for the file system that may contain millions or even billions of files, as it allows for fast, efficient access of their desired file. The another advantages of B plus tree file system is that they are able to handle large files efficiently. When a file is too large to fit into a single block, the file system is will split into multiple blocks and store each block into a separate node in a binary tree. This allows for efficient retrieval of large file as the file system can read the block into parallel from different parts of the disk. Of in addition to their use in the database and the file system, the binary positive tree are also used in wide range of applications. For example, they are commonly used using network router to manage the routing table, in search engine to manage the index of the web pages, and in operating system to manage the allocation of the memory. The binary positive tree have also been used in a number of research applications such as construction of geometric database and and stimulation of complex physical system. In this application, binary positories are used to efficiently store and retrieve the large amount of data and enable the researchers to perform complex analysis and stimulation. These are our reference, and thank you.
Thank you for listening to